Good morning, ladies and gentlemen. Thank you very much for coming to this public lecture, which is from right now to 12 noon. My name is Kazuya Kobayashi. I'm the general chair of this conference. And today's speaker, let me introduce Professor Ryuji Kohno. He's Professor Emeritus from Yokohama National University. And also, he's a vice president of YRP. Excuse me. Professor Kohno is a Professor Emeritus from Yokohama National University, Japan, and he's also Vice President from YRP, International Alliance Institute. Let me first introduce his background briefly before his lecture. Professor Kohno received his PhD degree from the University of Tokyo in 1984. He was a professor and the director of Center of Medical Information and Communication Technology at Yokohama National University in Japan from 1998 through 2021. And now he is Professor Emeritus. In his career, he played a part-time role of a director of Advanced Telecommunications Laboratory of Sony CSL during 1998 through 2002. And also directors of UWB Technology and Medical ICT Institutes of National Institute of Information and Communication Technology, NICT, during 2002 through 2012. For 2012 through 2020, he was CEO of University of Uru Research Institute Japan, CWC Nippon Company, and since 2020, Vice President of YRP International Alliance Institute. And for 2007 through 2020, he was a distinguished professor in University of Oulu in Finland, and since 2006, an associate member of the Science Council of Japan. In IEEE, he was a member of the Board of Governors of Information Theory Society from 2000 through 2009. And he also served as editors of several well-known journals. He is the founder and chair of the steering committee of the International Symposium of Medical Information and Communication Technologies since 2006. He is also the general and TPC chairs in many international conferences, including PIMRC99 and others. So let me invite Professor Kohno to give a lecture entitled Harmonization of Scientific, Commercial, and Other Radio Uses with Regulatory Science for SDGs. Professor Kohno, please.
Thank you, kind introduction to Professor Kazuya Kobayashi. He might be very tired for the entire organization of this very successful GASS 2023. I very much enjoyed the discussion. Many new knowledge I got from this symposium. Anyway, I'm very honored to give such a final lecture in this symposium, the public lecture. Public lecture means that anyone can listen to, not only such a participant here itself, maybe it is also connected to the networks. Hopefully the more old stakeholder of the such a radio science, also radio usage or consumers. Because the subject itself is more like harmonization for the such a scientific, pure scientific application of the radio and also commercial radio and others. That means more sometimes the contradictive use. Sometimes pros and cons. People argue much. In particular, I play a role of the such a chair of the regulatory committee in the government side, authority, MIC. That's what I know what's going on. Today, the subject itself is quite important for entire URSI, I believe, because anyone in any commission A to K may have more commit somehow, I hope. Okay, so let me start. Here is a background. Since the year 2011, in the GASS held in Istanbul, I play a lot of the such a harmonization or discussion with the ITUR, with URSI, and then every 2 years, I had also the keynote or something like AP-RASC2013 and also 15 and so on too. And then the last year, November, we have 100 years anniversary for the URSI-Japan. I also gave such a related this subject today. Okay, that's the background. The reason why public lecture speaker here. Here is the agenda today. First of all, let me explain about the necessity for the harmonization. And then the second, so many demand we have to use such a radio resource management. In particular, such a SDGs goal we're going to perform. And then I pick up the two major use case of the radio, like ultra-wideband radio and also wireless power transmission. These two are the very typically we discuss such argument, contradictive good and bad from the pure scientific users and also consumer user a lot. In my experience, that's why I pick up the more detail, these two subjects. And then the last, to solve such a problem, one of the common concept, that is a regulatory science. That's a new subject. I think you are not so familiar about that. I'm going to explain later more detail. That is one of the good concept. Then based on such a concept, we do more discuss fairly. That's the target. And then let me wrap up that discussion finally. Okay, obviously the radio astronomy observation or Earth Explorer satellite system, these are the passive receiver. That was not so easy to detect they are using or they are active or not, unlike carrier sensing manners. Yeah, that what we have to strongly protect against any interference for such a commercial use and so on, obviously. I myself am working at the Nobeyama radio astronomy observation. That what my main field is more commercial radio use or for communication, but I know both sides. That's the reason why I chair such a regulation committee and so on. Yeah. In fact, there's such a not only just a simple or contradicted issues like medical use or public use, like disaster prevention or remote medicine. That is more both sides, pure scientific interest and also quite the consumer size of the applications, right? That was not so easy to simply harmonize together. That's what we need more discussion to minimizing the mutual interference. That is a harmonization. It is. Okay, this is a necessity. Now talk about such a demand. How to smartly radio resource. That's also the subject. According to the drastic increase of such a radio usage, like a smartphone and so on, we have to think about such a primary and a secondary use in the radio regulation terminology. Of course, previously that was a more primary. Other one is secondary. But now also have to discuss the other way around and so on. That's the issue we have to keep discuss in the venue here at URSI, I hope. Again, that the frequency spectrum is a global common resource, isn't it? Anywhere in the world can fairly use a common resource. That's what we have to think about such a minimizing such a mutual interference result more improve the performance of all the radio used systems and so on. And then the fair discussion should be how to proceed it. That's the very difficult issue. But I said that based on the regulatory science point of view, that was mainly used for the medical field already. Let's use such a concept to the radio management. That's my presentation. Who can do it? That is URSI, because URSI, International Union of Radio Scientists, fully represented all of the stakeholders of the radio usage and so on. That was like pure scientific use, what I said, such a astronomy and also other use. But also the commercial, like Commission C used to working, is more biased to the commercial. But you see that the other commission also contribute how to measure the such interference to the victim operator and some others, and also the impact to the human body. And then the such a medical and a public use we will fairly discuss. That is the only one, so that is a URSI. No other place we can do it. It's a non-government organization, non-profitable organization. That's the reason why we fairly discuss. Same thing, again, at the needs for the scientific, pure scientific radio. Obviously, the more like academic research and also more scientific interest. But commercial use is more consumer electronics or some other business production and so on. That's a very contradictory. For instance, one of the radio astronomists also using a mobile phone or car navigation or collision avoidance radar and so on. That's both sides you are, right? That's the reason why we have to fairly discuss time to time what's a great way and so on. But once again, that the demand for the radio resource is quite key in global, like SDGs. You see that many of the issues in the social problem we can resolve by using a radio resource. That means it's a driving force. That what a dependable, reliable, secure radio resource management is a key for the SDG entire. In this case, the problem is how we can harmonize together all of the multiple usage of the radio. That's key point, is it? So one example in my field, like medical services. Anywhere in the world, there is no regional gap for the medical services. In this case, the radio connection is very work well. Actually, I work in many places like Africa and also some other Middle East, very sparse area like Lapland in Finland and so on. Equally, they support the people living there. Yeah? And then the other case like resilient infrastructure systems. You see here Japan, you are lucky there is no earthquake in this week, but we often have such an earthquake, and then coming the tsunami due to the earthquake. In the case of how we can predict such a disaster, in this case a wireless sensor node using a radio, that's also the one of the issues we can. This is just pointing out some typical application of the radio use for the purpose of the SDGs. Other smart city issues as well. I think not only these three, almost all of the 17 SDGs issue could be, resolved by such a radio resource efficient manners and so on. That's the reason why that we URSI can contribute for global services. Actually, I teaching at the university, most of the young students thinking to have write a paper to publish the journal and so on. Okay, it's important for their promotion, but don't forget your research work should be contribute to the real world globally. That's my teaching way. Yeah. Anyway, again, that the demand for the radio resource management for to achieve the SDGs is quite keen to resolve such an emergence problem like COVID and some other pandemics issues, and what I said, that the regional gap of the medicine, religiousity, and the shortage of the food and energy issues. How we can challenge it? Obviously, we do researchers to invent new technology to fairly, reliably use such a radio use for these solving these social problem. Yeah, this is primarily important, but not only just the research only. To make it more feasible, sustainable services should be done by commercial, not only just the government support system. More fairly business-oriented sustainable operation could be more longer life, isn't it? Right? Now, what we do more promote such marketing issues as well as regulatory issues. I work all of that in my life. And then the approach, once again, is already explained. That's enable radio and other related subjects like data science, AI, machine learning algorithm could be more deeply involved for the scientific use of the radio as well. Now, what we have to learn more related subject, not only the natural science like engineering, but also more regulatory or political science or economics or business administration we have to learn. Actually, I'm teaching at the business school as well. This is the reason why we have a discussion today here. I'm going to pick up the two typical use case we need to discuss and harmonize such a commercial and a pure scientific use of the radio. That is the ultra-wideband radio, UWB. In ITUR, about 10 years ago, I worked at the TG18 for the regulation, represented the Japanese regulator and so on. But still, it's an argument never ending because once it concludes, but already 10 years passed, we have to revise again. That's the reason why I chose the ultra-wideband radio issues. I'm a bit ashamed to introduce what we have my research field. I originated from the academia university. That was a more theoretical work, and I invented a new technology. That's a circle thing. Every 5 years, I started a new subject, and then totally over 40 years to work together. And then I also working in Sony or some other international big company, because I also wish to know what's going on there, because most of the students graduate from my lab also working in industry. The case the professor have to know the more industry side. Yeah, this is my mind. Same sense, I also represented the regulator side. Yeah, altogether such a multidisciplinary field of the research or concept, we have to teach, and to teach we have to learn first, right? That's the reason why. And then the many application use case also think about not only the theory, okay? So I pick up the two subjects, again at the ultra-wideband radio and the wireless power transmission in microwave band. About 10 meter, we can transfer the radio signal, power. That's also very feasible now, but it's dangerous for the scientific use, isn't it, right? More increase of the total radio emission power, including data transmission and the power transmission both. That's quite dangerous for the radio astronomy observation part. I published several books and so on. This is one of them. I worked together with my colleague when I was a director of Sony. These are also explained. Just one thing, you already know that what's a UWB, ultra-wideband radio. Essentially, the ultra-wideband specification, that means that the density of the spectrum is quite low, typically lower than the emission noise, right? That's why the people say that it has a very inherent property for less impact to the other radio or passive receiver, but still increase the noise, they said. Yes, that's why we have to prevent something other extra technology rather than the inherent property of the UWB. And then of course such a great work like impulse radio type of the UWB have a very precise ranging or localization like car collision oscillators and so on. It's a very successful business in a millimeter wave band. But it's very dangerous for the radio astronomy observation. In Nobeyama Observatory, we also check it. Very rare case, it's damaged, but not often. But still the very sensitive issues. And then again, I started from the channel theory, information theory. That means that the channel capacity C is in proportion to the bandwidth. That means the ultra-wideband radio has a ultra-wide bigger capacity or a higher speed data transmission possible. That's a very commercially available and even such a indoor localization if the GNSS is not available indoor. That's the other way around. That was pros and cons a lot. And then this is just a short explanation of the history and the trends. Before the year 2002, most of the UWB applied for the military. But after 2002, started US FCC allowed to use a civil use. And then the second wave came in the year 2007 or 2008. We have a more standardization of the body area network and some other UWB application, like ECFP7 and so on. And then the third wave came about the year 2018 and so on. The case that the more practical mass production of the UW devices. You may know that the iPhone 11 or so on have already installed such a UW chips and so on, right? That's more commercially widespread. And the last stage now is a very diversing the usage. I think within a few years, such a UWB device could be replaced with such a Bluetooth and so on, because a much better performance. Yeah. And then the device the shipment and also chip revenue is drastically increasing this decade. That's why we have to take in care how much we reduce the interference to the pure scientific usage. It's dangerous. That's what I also promote to the more regulatory meeting and so on. Originally, the application, major application, killer application of UWB is mostly for the consumer electronics, like a peripheral for the personal computer and so on. But nowadays, more successful for the collision avoidance radar or automotive industry and so on. My car, also the keyless entry, that's also using a UWB, right? That's the mostly for the ranging issue rather than the capacity of the transmission data and so on. But a more point, what I want to talk today is a medical application. Like a medical body area networks, BAN, B-A-N, is quite key for the application like this. Wearable band collecting such a vital sign like a ECG and so on. In a COVID case, that SpO2 value also remotely monitoring. Don't have to go to the hospital. The clinician don't have to meet such a patient or possible patient. And then the other more implanted one, like a brain machine interface and also capsular endoscopy, is quite successful now. I'm going to introduce something more. In this case, the ultra-wideband radio is chosen for the transmission system because, again, the inherent property of the less impact to the human body and also other coexisting like a pacemaker and so on. Yeah? And then not only that interference to the other radio, the UWB also very spread wider. That means in the sense of the frequency diversity effect, that was the less impact from the other narrowband interference to the UWB system as well. But anyway, these are the reasons why. One of my success is that dream come true. Actually, it was a scientific fiction in the case of such a capsular endoscopy, tiny one. We introduced the two camera, like a stereo eye, and also manipulator, and also nano laser. altogether, and without the battery. We introduce a microturbine, and then inside the blood vessel generate electricity, while the people are alive, keep working forever. Yeah? That's the reason why such a dreamy subject, many younger students also interested, and then coming to my laboratory, and then I teach more global issues, like not only the technology, but also more common sense or ethics issues as well as the regulation. That's a task for the professor, I think. This is also the issue for the precise ranging or indoor radio, like anchor node setting up the indoor. And then we keep tracking the mobility, not only just localization, keep tracking the mobility. And then in some case, that motion capturing also available using such a UW device and so on. I have no time to explain much. That what again at the body array network, you know the government in Governor Kuroiwa in our prefecture is a state or a province, decided to use distribute such a body array net for the citizens. And then the citizen health condition. Elderly people, younger people keep watching because collected vital data through the 5G cloud networks. Altogether, big data is analyzed by the machine learning algorithm, work together with IBM or Fujitsu data server analysis. And the result feedback to the own user or clinician and so on. That's ongoing now. This is the one successful under the COVID-19 case. The home quarantine time. The patient wear the body network, all of the vital data remotely monitoring. Then it's a very safe, isn't it? And then also the other case, like student or laborer working at home because no need to go to university hospital, the working place. In the case, the problem is not only physical problem, but also mental problem in such a worker at home, like Asperger syndrome and so on. That's what we do analyze using vital sensors. You introducing a sophisticated brain-machine interface system or some other machine learning algorithm and so on. Outdoor case, not only the human body, but also the wheelchair, we set up the body area networks. And then we remotely monitoring the condition and navigate the wheelchair and so on. Yeah? I stopped talking some example, but you can imagine how widely applicable the UWB is. Again, that the ultra-wideband radio band body area network has a star topology, the one coordinator hub, and then connecting all of the vital sensor or actuator, dual transmission, not just a sensor node. And then all the connected collected data at the hub coordinator. It also works for the firewall. And then using such a already existing 5G, 6G networks, and then introduce such a big data for the data mining and so on. Yeah? I have a very successful international project like Middle East. In the like Abu Dhabi, many people are the diabetes patient. The case that the wearable insulin pump together with such a glucose sensor connected by the body network. And then remotely monitoring glucose level, level and also blood sugar level, and then also decided how much amount of the insulin inject. Such a feedback sensing and control loop is very successful. In the other application, like worker in the offshore of the oil plantations, over 50 degrees Celsius, people suddenly die. That was to protect such a worker at a very serious situation. We taking care of the laborer's health condition, like that. It was very successful. And then the year 2020, the Tokyo Olympic Paralympic time, we also introduced such a body network for the equipped for the para sports athlete and so on. Like that. Another application like disaster prevention, the year 2011, we had a big earthquake in the northern part of Japan. It's a Pan-Pacific tsunami. came to the Christchurch, New Zealand as well. Now we have a joint project together with University of Canterbury, and then they work together to make a new system like this using a UWB technology for drone flying. At the beginning, it used like a GNSS for localization, but inside such a nuclear reactor indoor case, we cannot use the GNSS. Then we use such a 3 of the out of the 4 drone is work as an anchor node, and then identify the fourth one. Iterative manner, we do it. And then without the GPS systems, we found a victim searching. And then the victim where the body of the network, we collect the vital data, and then they use for the triage, who first to help, who's next, and so on. In the case drone can only fly less than 1 hour. That's why we introduce a wireless power transmission, relay for the multiple drones. That's also the second subject what I'm going to talk. And then this is a polo field of the Canterbury University. 4 drones coming to find such a victims, missing victim. That's not only the such a, the disaster areas. Maybe some Alps, some climber missing, we can also apply that too. Once again, that already the well-known the 5G existing, also data mining server also exists. And then key point, how we can collect the pure reliable data and also how remotely control. That's the work for the body area network BAM. So you may know the international standard like IEEE. The Wi-Fi radio wireless LAN is 802.11, but we more focus on narrower communication range. That is more like 802.15. Yeah, we working heavily using a UWB technology applied for the keyless entry like 15.4Z. And now the new generation of the UWB PAN is a 4AB. And also I chairing the dependable body area network for not only the human body for healthcare, but also the vehicle body application for the autonomous car driving and so on, because it's a bigger market. Yeah? Then the successful without any government sponsorships. Yeah? Oops, sorry. I bit heavy to talk. Sorry, speed down to talk now. Again, at the year 2012, when I was the director of the NICT government Japan for the leading up the group of the UWB and the medical application, we established the standard of the 15.6 standard for the wireless body area network. And then the 10 years passed. This is the time for device. And then we make it more dependable. And then the application range also extend to the car body as well. Yeah. This is last month in Berlin. We have an interim meeting in Berlin. And then the next month, September, I'm going to Atlanta to other plenary meeting for the IEEE.15. And then meanwhile, the necessity of the enhanced dependability. Because of so many bands that the penetration ratio higher, that means even the same standard system coexist, that will interfere each other. That was such a coexistence issue for the same standard or different standard or non-standard system, even non-commercial system like pure scientific application, how we can ensure the coexistence. That's a subject in the current revision of the standard of the body area network and so on. And not only the physical layer, but also the media access control. That's also a key issue for avoid such a contention of the packet and so on. One of the typical applications for the medical field, the top brain surgeon, we also work together. Inside the brain skull, we're setting up the 100 sensor node, electrode, and then all of the vital data, collected the ECOG data, transmitted by UWB because less impact to the human body. And then it's analyzed by machine learning algorithm and also control the robotics or speak, even such a person who cannot speak. Yeah. And then the car application also, once again, make a bigger market in the commercially sustainably operate that the targeting. The standardization purpose is, again, making a market, isn't it? Okay. Then, of course, one of the examples, like a senior driver make such an accident, traffic accident often, right? Like me, not me. But in the case, the car body body network identify the human body sense the information and then communicate to each other because the same standard system. That was easy to analyze. Driver can stable condition in mental, physical. That's also one of the big issues for the car manufacturer. European, American, and Japanese car manufacturer funding this activity well. Okay. So again, many of the commission here also contribute such a modeling of the channel and also measuring channel, wearable implant, and some other, even such a car surrounding area. This is one of the examples for the combined human body and the car body body area network applications. Where the body area network passenger ride on the bus, and then the bus coordinator identified who you are, and you already paid charge and so on. One of the sad accident happened in Japan. The school bus, a small kindergarten kid remained in a school bus. No one didn't know that and they passed away. Too sad, isn't it? Right? But this application, the kindergarten student wear the body network, and then the bus also identify health condition or existing indoor inside the car, bus, and so on. Right? This is also solved such a big problem that people are very interested. Have intention and so on. Yep. Again, at the many type of the coexisting we classified, including such a non-commercial, like a pure scientific application as well. And then we categorize the class of the coexisting 0 to 7, totally 8 classes. Like 1 or 2 is the same standard level of the system. We know the specification of the radio standard. That was easy to resolve such a coexistence. But 4, 5, 7, and so on, we don't know the exact specification, non-standard system or what's going on. The case that we need to have a more cognitive sensing and so on too. Such an easier problem to a difficult problem we do classify. Like intra-system interference or inter-system interference. We know that such a pre-knowledge or without pre-knowledge. That's a big difference. In commercially available, avoiding the interference and so on with low cost. Because if it too cost much, then never useful at all. Yeah. And then this is one of my invention. You see the impulse radio. If we design the good shape of the pulse, and then you see that there are 2 notches. That means coexisting with a wireless Wi-Fi radio, like that. That would just simply design the pulse shape is good enough. That's easier to implement, isn't it? Yeah. And then we also take into account such a priority or QS level of the packet, like a very critical, life critical packet. We have to transmit without any error or without any delay, and so on. But you see that the Shannon theory said that the channel capacity is an upper limit. That means that to perform the higher priority security or reliability for the QS level higher one, we have to sacrifice such a lower one. Yeah? That's a concept, exactly. And then we design the different channel coding according to the required error collection capability and so on. I skipped this one because of too much detail. And then once again, the 8 level of coexistence and 8 level of the such a QoS level, totally 8 times 8, 64 classes of the combinatory we design specification. And then now is which situation we identify by such a cognitive radio sensing manners using such a preamble or CCA period, clear channel assessment period, and so on. One of the MAC media access control data link layers, we introduced some sophisticated hybrid contention-free and contention access protocol. The higher QoS level of the packet, we have to guarantee the delay. That was a contention-free period. We preserve the packet time period. Although there's such a low QoS level of the packet sacrifice, we need to we introduce a contention access period like carrier sensing, then the retransmission gain, and so on. That's on and off, the higher priority or lower priority, we have to take into account. Yep. Time is consuming, that's why I skip it. Now the time for almost the end of the standardization. About 1 year, we complete the standardization. That's what I mean. Meanwhile, we try to introduce some discussion with infrastructure network like a 3GPP, like beyond 5G. You know that I'm working in the University of Oulu, Finland. That's also the 6G flagship. My colleague, Matti Latvaho, also working heavily. That's the reason why we're working. And then about regulation issues. UW regulation is not common in the world. Even we discuss ITUR, TG18, not enough. But UWB band is somehow very close to any region or countries. Actually, Japan is the most conservative, but now that we have a more developed, the almost similar regulation for Europe. Yeah? And then we categorize the possible victim systems interfered by the UWB. Category 1 is not difficult. Category 2 also not so difficult. But the category 3 is a passive receiver. That's not so easy to identify. But you know, the radio astronomy observation, we know where it is locally. It's not moving, right? But you know, Landsat satellite and something also schedule where it's coming to the, this area and so on. That's what we need to have a more extra information to avoid the interference and so on. The microwave band, the millimeter wave band, different approach we did it. Yeah? And then one of the issues, like category 1 and 2, we can detect the signal or carrier sensing. Then we avoid the interference. That's easier. Yeah? But category 3, like a passive receiver, we just introduce some low duty cycle. That means the average emission power could be minimizing. That is one of the way at the moment, this feasible solution. But we have to find something better. And then the remaining issues, the primary, secondary issues we have to discuss. And then also the technical solution, as well as a legal solution we have to think about. Yeah? And then the ITUR, the WAC 23, are going to held in Dubai this November. One of our Japanese regulator also commit strongly about these issues. Yeah? And then the last, second one, still, well, time is limited. That what, I can skip it, but let me explain about the wireless power transmission quickly. You see the Japanese cabinet ministry also working heavily about WPT, wireless power transmission in microwave band. In this case, we're talking about the far field WPT using a microwave. You may know about the principle. That's why I skip it. Using a beamforming transmitter and also rectangular antenna or rectifier in the receiver side. It's just a simple explanation. But you see that the key point is the, due to such a path loss, the transmission channel has losing the power, and also the receiver side in the rectangular also have a power conversion ratio is not so high yet. That's what these two are the quite key essential subject we have to solve. And then I have a several application, but this is just three different categories. One is factory automation or IoT, mostly for the industrial application, and also the medical application, and also more home use. And the third one is a much longer distance transmission and a higher power. That's the third one. These are categories. Also, we discussed in the regulator in Japan, Ministry, Internal Affairs and Communication. The step one already over last year. About 1 watt we can transmit, but mainly for indoor. But step 2 is the next year we complete, somehow outdoor and a higher voltage. And the step 3 we scheduling the 2027 and so on. But anyway, these are also scheduling, but the time is limited. Let me skip it more. Yeah, the frequency like 920 and also 2.5 and 5.7. Actually, these frequency is more somehow the industrial application and also Wi-Fi radio coexist together. That means within the commercial usage, still the data transmission, the power transmission compete each other. We also introduced some regulatory science approach for such a such a commercial use as well. So before talk about the regulatory science issues, just quickly explain the integrated wireless power and the data transmission theory, because I'm a theorist first. That was introduced existing communication theory, apply for the WPT in a sense, like access control. Usually the power transmission uses such a single tone, sinusoidal. But if you packetize, like a data packet and also power packet, it could be, access control to avoid the contention, and so on. And the routing is a network layer, also to avoid the interference to the human body or pure scientific application, and so on. Yeah, these are also key for the theory, because most of the research is done in a circuit level in a WPT. But from my point of view, such a MAC protocol routing algorithm quite key for resolve such as step 2 and step 3 or the realization. Yeah, and then this is one of the multi-hop relay in the physical layer. To transmit over 10 meters, we need to have a repeater or multi-hop relay we need. In this case, obviously such a repeater has more loss at the power conversion. Although the distance is longer, is a propagation delay, propagation loss is also big. That's what optimization number and the spacing of the relay, how many relay we need to solve. But in some cases, we have some terminal or relay which can be power boosting and so on. Many realistic approach we do, and also propose such a routing to avoid the interference to the human body, and also scientific use and so on. It's a routing algorithm. Altogether, the communication theory could work for the wireless power transmission for peaceful harmonization within the commercial use, or even such a scientific use too. Sorry, I rush up. Once again, I'm going to talk what's the common solution that is a regulatory science. Now the main part, what I would like to talk. Well, you see that this is a case of the medical application. Regulatory science is quite popular in the medical field, in a sense, like a high class of the medical device has a very beneficial, but still the many risk a lot. For instance, that some patients have only the 3 months lifetime remain. The case that the clinician or surgeon said, if we introduce this medical device, your life extend 5 years. That's good enough to inform, because most of the patients say, yes, please use it. But that the system newly invented, there is a big risk. Nobody used before, like that. That was in the operation time period, sudden die and so on. Such a risk versus benefit, we have to clearly inform to the patient or user. The same sense in all stakeholders of the radio users. Maybe some part no, but not yet. And some kind of the fake news or fake information, people are confusing. Right? That's why we have to clearly explain such a risk versus benefit. That's the reason why the medical device take a longer time for the higher class of the medical device case. We introduce such a regulatory science in the case of the medical device or medicine drug. Newly invented the drug or medical device. Of course, again, the pros and cons, benefit and risk. We have to clearly numerically evaluate by defining the parameter or criteria for the risk versus benefit. Such a scientific approach differs from the social science. And then we make a regulation rule. What the range of the transmission radio emission power could be available or permissible. That's an example, right? And then the fourth one, how to measure. Yeah, this is also task for the Commission A and so on. And then the procedure to the compliant testing of the medical device regulation and so on. Altogether, the speed up the procedure of the regulatory compliant test, and also not only the patient, but also the manufacturer also protected against any attack and so on, because it's compliant already. Yeah, and then this is already obvious when we apply the radio emission medical device. If the emission power is too high, it's dangerous for the human body, but the SNR is high. That means the bit error rate is low. Vice versa. Now, what permissible range of the such a emission power is one of the regulation parameters. Is it? Now, what such a regulation due to the the regulatory science is a key. Actually, we established the Regulatory Science Center for the Medical Device and Services year 2012 in Yokohama. That's the largest seaport in Japan, just next door of the Tokyo. Largest, second largest province or prefectures in Japan. We worked together with my Finnish colleagues, and then we started SAB. We tried to introduce such a medical device success of the regulatory science to the harmonization for scientific and the commercial use of the radio. You see again that all of the such a different use case, we apply the regulatory science to harmonize. In a sense, how measure the such a risk versus benefit using such a right proper parameters or criteria, and they decide such a technical conditions for the regulation and so on, and the manner of the how to comply, compliant test and so on. Yeah, and then the almost end of my talk. You see again that to manage the balance in between the risk versus benefit, don't forget the cost. If you remove the interference with so high cost of the system, no one uses it. But we also take into account the cost as well. And then the technology is not perfect. That what remain the uncertainty, we have to clearly reveal. Okay? That's the concept of the regulatory science. Oops, sorry. Again, at the numerical evaluation of the risk versus benefit and the definition of the permissible range of the parameter, and also making a regulation by such parameters or range, and then the measurement method and so on. Of course, all of the researchers have to contribute to invent such a newly feasible solution, enable solution for avoid the interference each other. Okay, and then the regulatory science used to be called the science for agreement. All of the stakeholders have to agree or get the consensus. Without any complete understanding each other, we cannot satisfy at all. Take a time, but more logical manner of the procedure we do based on the regulatory science. I was working long time, and then the URSI has a commission A to K and then they contribute such a regulator ITU and also CISPR and some others. And then this is just an example. Not only the all commission, but also some specific commission can commit for the part of the such a procedures, action. Yeah. We are in Japan, we establishing, preparing the such a regulatory science center for the harmonization of all of the regulatory use of the radio, together with a regulator or academia together. And then I skip talking the task each other. So many tasks of the individual commissions. At the end of my talk, obviously this is good for solve the emergency social problem, and social impact is high. But one thing more I have to point it out is the academic impact. Regulatory science is an inter or multidisciplinary research field among between such a social and the natural sciences. That means we do educate the people, such a regulatory scientist who has a well balance for both scientific innovation and also regulatory commitment. That is a task for the URSI, I think. Let me wrap up my talk. You see that the commercial radio usage is quite increasing a lot. But we also have to produce some innovative technology, and then very useful for the commercial or medical usage for entire SDGs. But pure scientific radio use should be protected against such interference, while the commercial radio has technology to how to avoid physical layer, macro layer, network layer, how to avoid the interference to the radio astronomy and so on, based on such a regulatory science. And then the URSI must be the unique best venue to harmonize such a scientific and commercial other use of the radio as a scientific subject we do more promote. I can say that I would like to propose for the motherboard of the URSI members. We wish to establish some kind of the special working party or working groups for the regulatory science, hopefully. If you agreed, I can contribute much. At the end, the URSI can be truly contribute for the global peaceful life, including some world peace without any war and so on, invasion and so on. Regulatory science is quite important for the science for agreement, once again. Thank you for your understanding what I talk. That's it.
Thank you very much for your very nice and interesting presentation. We have several minutes for discussion. Are there any questions or comments? Yes, please. Would you please come over to the microphone and speak?
Ron is from Australia.
Yes. Silo.
Thank you. Very interesting talk. In relation to your ultra-wideband use of pulses for communication and other reasons, that made me think, in the past, we have regulated the spectral frequencies at which people communicate. Mm-hmm. Do you think in future there may be a regulation of the time in which people send pulses? Because time can now be distributed accurately. So you could imagine on every UT second, somebody has permission to send a pulse. Is that a future?
Yeah, essentially I'm not the perfect answer for your question, but I haven't. But you see that time to time, maybe the URSI keep monitoring the condition, like a neutral position, who passed the regulation or something. That's also the task of the URSI, I hope. And also the one related issue, like emergency period, like typhoon or some earthquake happen. The regulation must be different from the normal situation because we have to take care of the victim. In the case of the emission power, the UWB or some other could be allowed to higher. Although there's such a radio astronomy observation side is not agreed, but your relatives are dying in the case that maybe you agree that, isn't it? Like such a regulation also have to more dynamically available to change and something I wish to say. Thank you.
Any other questions?
They wish to go to lunch. No?
No, the closing ceremony is going to start.
Oh, okay.
Before lunch. Any more comments or questions? Okay. So thank you very much once again, Professor Kohno.
He has some.
Oh, yes. Yes, please.
Thank you, Professor Kohno, for the very interesting question.
I can hear you.
Can you hear me?
Yes.
Yes. So thank you very much for the very excellent talk. So I'd like to know about how to coordinate the different stakeholders, because I just imagine that my idea might be too simple, but for the medical applications, I just wonder that the risk and the benefits are dedicated to basically the same persons, same group of persons. But for the spectral harmonization, which you mentioned, obviously those who get the benefit and those who are threatened by the risks are basically different. So how can we extend this idea of the medical application to this harmonization? Could you mention a little bit? Because I think it's a very big topic, but just let me know about this contrast.
Yeah, it's hard to answer for the query for your question. We also argue in such an issue. The current situation in a medical field, like a hospital, we reveal all of the parameters, even such a patient himself or he or herself or relatives, but also some kind of the open public, how dangerous and so on. Of course, we don't know exactly what the remained uncertainty and so on. But we said, we know only this part. Other part is not clear yet. But still, would you like to use it or not? The judgment might be done by such a patient or relatives, right? Now, what a stakeholder, of course, discussing commit how to manage that one. But the decision by such a person who have suffered, and so on, like that. This is just one example. But your mentioned thing is more complicated, more different stakeholder, just thinking the manner of the regulation. But also, if we are exactly facing such a trouble, maybe change mind and something often happen in the daily life too. Yeah.
Thank you very much.
Thank you. Yeah, that's the reason why this is not so easy to solve. That's the reason we researchers to challenge, to prevent something new paradigm for research, isn't it? Thank you.
Any other comments or? Okay.
Yes.
Yes. Oh, yes.
Thank you very much for the very exciting talk, and which URSI should feel responsibility for it. And in your talk, the typical victims. For example, on your page 65, amateur radio and radio astronomer, I understand. But, there are a variety of discussion for the wireless power transfer, and very similar topic was, I experienced, power line communication.
Right.
Many radio scientists want to radiate the power, but the power line itself wants to confine the energy. That's why there were several conflicts in it. But anyway, URSI should be the place where everybody discuss intensively, scientifically, in fair manner. This is your message. Thank you very much.
Thank you. That's right. I also have a same question about such a wired, power transmission in cable. Power communication, a power line communication case. That's also we solved such a solution because the power cable used to have an antenna leaking. That water surrounding system also suffered, right? That's what you talk. In the time, we also invented the technology. Let's use the similar technology for the wireless power transmission as well. We have a bunch of the result previously, some similar application. That's your suggestion. Thank you for your attention.
Okay, so the time is running out. So thank you very much, Professor Kohno, again for your very nice and excellent presentation. Thank you.
My honor. Thank you.